Classifying matter, looking at the separation of different types of matter by their characteristics. State is one way that we will identify or classify matter. There are three basic states of matter. We have solid, liquid, and gas. Solid is a substance defined as a definite shape and a definite volume. These solids will be static, which means that they are not mobile. Their atoms will stay in place. They are incompressible. You cannot force them into a smaller volume. They have a high density, which means that the amount of mass is packed into a small volume. They have high attractive force. That means their particles will generally attract to each other strongly. There is essentially no separation between their particles. A liquid will have an indefinite shape, which means its shape will change, but it has a definite volume. Think of pouring water on the ground. The volume of the liquid will remain the same, but the shape will change. Liquids are fluid, which means that their particles can move, but they are also incompressible. They have moderate density and moderate attractive force, but they do have a low separation between their particles. However, those particles will remain relatively in contact. Gases have both an indefinite shape and an indefinite volume. They will expand to fill their container entirely. Gases are fluid, which means their particles can move. They are compressible. We can force them into small volumes. That's why we have compressed gas cylinders. They have low density because their particles are widely spread out. They have low attractive force, and they have a high separation between their particles. If we think of an analogy, a solid is kind of like an overcrowded subway car in some place like Tokyo or New York. You have a lot of people packed together and there's really no room to move around. They just kind of have to stand or sit in place. A liquid is kind of like going to a packed shopping mall up in somewhere like Memorial City, where you've got a lot of people moving around, say on a Saturday, but you're still able to move past one another. And a gas is kind of like going to somewhere like Big Bend National Park, or out in West Texas, where we have lots of room to move around. Now, the other way that we classify matter is by its composition, what it's physically made of. State can change within the same type of substance, but composition will not change without changing the substance in most cases. The exception to that is mixtures, as we'll see. Now, when we look at composition, there is a rather large tree diagram breakdown of matter by composition. Matter will initially break down into either a pure substance, which has a single type of substance, or a mixture, which is a combination of two or more substances. We have elements and compounds as a component of a pure substance. We have elements that are atomic or molecular, and we have compounds that are ionic or molecular. Our mixtures classify as either homogeneous, which we call solutions, or heterogeneous, which we call suspensions. So looking at these classifications, pure substances have a single component. For example, water, oxygen, table salt, all of these are pure substances. An element is a type of pure substance which cannot be chemically simplified. There is no further breakdown without destroying the matter into subatomic particles. An example of an element is an atomic element like sodium. Sodium is an atomic element. It exists as a metal with a single type of atom just kind of strung together. Chlorine gas is a molecular substance. You have a molecule formed from the combination of two atoms of chlorine. But because both atoms are the same element, it is still an element, even though it is a molecule. Our elements are represented by elemental symbols. There are a total known number of elements at 118. Now, compounds can be simplified by chemical means. We can use some sort of chemical process to separate them into their component elements. They will be invariable in composition, however, which means that something like H2O, water, will always be H2O. If I changed that ratio to H2O2, I would no longer have water. An example of a compound is either an ionic or a molecular compound. An ionic compound is something like sodium chloride, formed from charged particles called ions. Something like water, H2O, is a molecular compound made of the combination of atoms of two different types of elements. Our compounds will obey three basic laws. The law of constant composition, which says that the ratio of the two elements to each other will always be the same for a particular compound. Water will always be H2O. the law of definite proportions, which means that we're going to combine our elements in whole number ratios. And the law of multiple proportions, which means that we can combine the same elements in different ratios to get different compounds. Again, the example H2O is one compound, H2O2 is another compound. If I look at calcium carbonate, CaCO3, that will always consist of 40.1% calcium, 12% carbon, and 47.9% oxygen. A compound loses the properties of its components. It means that for example, sodium chloride loses the properties of sodium and chlorine and gains new properties. Mixtures, unlike compounds, can vary in the amount and the composition that they have. A mixture is a combination of two or more pure substances. They will retain their chemical identity. That means if I mix something like sugar and water, the sugar keeps its chemical identity and the water keeps its chemical identity. They can vary in composition. We can have solutions of 5% ethanol or 70% ethanol in water, and it can have a large range even though we have the same thing, ethanol and water mixed together. Think of different alcohols like beer or wine or vodka. Those kind of different alcohols all have different compositions of alcohol in water. There are two different types of mixtures. We have homogeneous mixtures, which we call solutions. These are uniform in their appearance. They have equal sized particles, which means they cannot be separated by filtration. The example that we used of a combination of ethanol and water is a homogeneous mixture. We have a solution of ethanol and water. Heterogeneous mixtures, called suspensions, are going to look different throughout. They're not going to be uniform. Their components will either be visible directly or through some sort of identification method. If we look at a mixture of sand and water, that's clearly going to have a difference between the sand and the water. Now, some different types of solutions may look, or some different types of suspensions rather, may look like solutions at first, but if we shine a light on them, we can activate what's called a Tyndall effect, and we can see the particles. It becomes cloudy. So some things may kind of look like solutions, but they're not necessarily. Now, a mixture can always be separated by physical means and restored to its original components, unlike a compound which has to be separated by chemical means. Distillation is one process to separate a mixture. You heat it up and it removes the two components. If I take salt water solution, for example, and I heat that up, I'll evaporate the water and leave the salt behind. Filtration is another means of separating it. If I take a solution or a mixture of sand and water and I run it through a sieve, I will catch the sand and let the water pass through, which will separate the mixture.